Thank you for the kind introduction, Chairman of the session, co-speakers and the learned audience. I am very happy to be in this conference because the subjects have been so well selected that they are falling in place like a jigsaw puzzle. So Dr. Khanna has made my job very simple because he has explained three-layer polyethylene in so much details, and I will be taking one of his point and elaborate it further, like better material selection methodology, which in the first place gives good corrosion protection. So as a pipeline professional, all of you are well aware of the three-layer polyethylene and polypropylene coatings for oil and gas pipelines as well as water for corrosion protection. Today I will be presenting three new innovations in this field. So I will basically touch upon the three-layer polyethylene coating market, current solutions, new innovations in line pipe coating as well as field joint coatings. I'll just skip the introduction, just say a few about Buruj. Buruj means actually Burj or tower in Arabic. This is a company which is a joint venture between Abu Dhabi National Oil Company, which provides the feedstock and the capital, and Borealis, which is a major petrochemical company in Europe who provides the process technology. Abu Dhabi-based investment company IPIC, they now have majority stock in three major polyolefin companies in the world, Borouge, Borealis and Nova of Canada. And combined capacity of these three companies today is 10 million tons per annum. So it's a huge group at the present. Borouge basically manufactures polyethylene and polypropylene materials for advanced packaging, automobile, and especially for infrastructure, which includes wire and cable, pressure pipe, and steel pipe coating, which is today's subject. If we look at the global market for steel pipe coating, as per the latest AMI study, three-layer polyethylene and polypropylene coating put together had a share of 73% out of the total area covered by various protective coatings. And if we consider the total tonnage of various coatings, it is close to 92%. Hence, they are currently the most acceptable mode of coating in the pipeline industry. The pipe coating market trends are also changing with time in terms of speed of construction, new techniques getting introduced to reduce construction cost, economic and political considerations dictating pipeline route. Three-layer PE continues to dominate the onshore market with water pipelines taking major volume share. New technologies for field joint coating and inner lining of pipes are getting introduced to increase the design life. And in offshore, thermally insulated polypropylene, thermally insulated pipelines is spurring growth in polypropylene coatings, which can be three-layer or multi-layer polypropylene, up to 7 layers. Coming to today's topic, the main criteria for selection of coating material for a pipeline is often the operating temperature. However, as per the latest ISO standard, definition of design temperature must include maximum and minimum temperature likely to be reached not only in operation but also during transportation, handling, installation and operation. Just to illustrate, if a pipeline with 0 to 60 degree operating temperature is to be installed in Turkey and the pipeline is coated and transported from Russia during the winter time and stored in Turkey during summer, then the operating temperature may be 0 to 60 degree, but the total design temperature should be considered as minus 20 to plus 70 degrees centigrade. So this is the background principle behind several innovations which I'll be showing in the next slides. One of the project example is Nord Stream pipeline, in which major part was coated in Russia and transported long distance through winter. The first specification draft was three-layer polypropylene. This could have been a disaster considering the low temperature brittleness of PP. However, it was changed in time to three-layer polyethylene and the coating damage rate was 1 pipe in 10,000 pipes. Similar examples are Chad Cameroon pipeline or different phases of IGAT or South Pars in Iran, most of which were successfully done with three-layer polyethylene system using bimodal HDP top coat and grafted adhesive. Now, one of the major innovations in the late 90s in 3LP coating was moving from unimodal medium density polyethylene top coat to bimodal high density polyethylene top coat. In bimodal process, the polymer is produced in two reactors, like you can see a loop reactor and a gas phase reactor, which is used by Borouge, and similarly there are other bimodal processes. Thereby it gives the polymer a broad molecular weight distribution or a bimodal molecular weight distribution. What does this do? Basically, bimodal molecular weight distribution adds more high molecular weight component in the polymer compared to unimodal, which is produced only in one reactor, represented by the blue line here. So here there are more high molecular weight components, which gives you more mechanical properties, melt strength, and stress crack resistance, whereas there are also more low molecular weight components, which gives you the processability so that you can extrude these polymers without any surface defect through your coating extruder. Bimodal polyethylene substantially increased the polymer's resistance to stress cracking, moisture barrier, abrasion, and low temperature impact, and also improved the processability. The new innovation targets are to exceed the limits of the standards. Currently, if you look at the ISO 21809-1, the standard for MDP HDP, which is class B, the design temperature range is -40 to +80 degrees centigrade, and for polypropylene, which is class C, is -20 to +110 degrees centigrade. Low density polyethylene coating is more or less obsolete now. Therefore, the new innovation opportunities are in 3-layer polyethylene system with better high temperature resistance, 3-layer polypropylene system with better low temperature resistance, and field joint coatings which should meet line pipe coating specifications. In Middle East and other warmer regions of the world, coated pipelines are stored outdoors in hot climates. Surface temperature during the day may reach 80 to 90 degrees centigrade. Storage period gets extended due to project delays or land acquisition problems. More damage possibility of coating is due to construction in remote areas, rock impingement on the surface, horizontal directional drilling operations. Now, black polyethylene is excellent against UV radiation and damage resistance, but temperature resistance is rather limited. The requirement for the colder regions of the globe is already taken care by the existing 3LP materials available, which can take care of -50 degrees centigrade to +80 degrees centigrade. But there is requirement for the equatorial region or the warmer countries for onshore pipeline coating, which can handle at least +90 degrees centigrade, which will cover 90% of the onshore oil pipelines. Here you can see how over a period of time, due to the innovations in polyethylene, the design temperature range as well as the mechanical protection improved by shifting from low density polyethylene based 3LP coating to MDP system to HDP system to bimodal HDP system, and the latest is hexene based bimodal HDP. Now, what is hexene based bimodal HDP? The standard polyethylene which is used for coating is a butene copolymer of polyethylene. The density we have increased substantially, which improves the Vicat softening point, thereby the design temperature of the pipeline. It improves the indentation resistance. It improves the moisture line regions, provide the main mechanical properties of the polymer. Now, because the amorphous region is stronger, it doesn't allow any notch or scratch on the surface to propagate to them and form into a crack under temperature and pressure cycling. Now, going by the book, for any pipeline project with 90 degrees centigrade design temperature, anybody will select 3-layer polypropylene today. But by using this hexene-based bimodal HDP coating, one not only saves raw material cost compared to polypropylene, but it takes advantage of the very high UV stability of black polyethylene, which is a big weakness of 3-layer polypropylene coating. You cannot store 3LPP coated pipes outdoors for 2-3 years. This new generation coating has already been approved by Gasco, Zadco, KOC, Oman Oil Company, PDO, Shell, and various other companies. As an example, data from PQT of Zadco Upper Zakum 750 MOL project is given, where many tests were done at 90 degrees centigrade against the project specification of 65 degrees centigrade, and values were far exceeding even 65 degrees centigrade requirement. Now it is time to go to colder regions. in recent South Stream project, which was one of the major pipeline projects carried out last year, for coaters in Russia, the transportation of PP-coated pipes to the harsh winter condition was a big challenge, as the standard PP systems would not survive. And therefore, a tailored system was developed for lower temperatures, consisting of a low temperature PP adhesive and low temperature PP top coat, which still fulfills ISO requirements. In Russia, coated pipes are evaluated at full-scale impact tests using different epoxies in a freezing chamber under controlled conditions, starting at 23 degrees centigrade, going to 0 degree, and then in 10 degree steps down to minus 40. The South Stream project spec was more than 10 joule impact per millimeter of coating thickness at minus 20 degrees centigrade. Now, what we found in laboratory testing is that the standard PP withstand 10 joule per millimeter, but cracks around 11 to 13 joule per millimeter. As against this low temperature polypropylene could withstand up to 26.9 joule per millimeter at minus 20 degrees centigrade. In field testing at minus 20 degrees centigrade at the coating company Vixa Steel in Russia, low temperature PP could withstand impact up to 21.4 joule per millimeter. The standard PP fell between 10.8 to 11.5 joule under the same conditions. These were the conditions of standard polypropylene in Russia after storage at minus 30 degrees centigrade. In Russia, they also do a special test called wagon impact test, where the coated pipes are stacked in a wagon which at a certain speed is made to collide with a static resistance. The standard PP completely cracked, and it was mostly on the floor of the wagon after the impact test at minus 30 degrees centigrade, whereas the low temperature PP system successfully survived it. For low temperature PP, the first impact cracks were detected only at minus 40 degrees centigrade. The non-critical temperature was found to be around minus 35. At minus 30, the impact was more than 16 joule per millimeter, which is still far above the requirement of the specification at minus 20. And after these so many temperature cycling, the peel strength was tested and it was found unaffected and still more than the ISO requirement. But we are doing continuous improvement on mill applied coating. What about field joint coatings? It is imperative that however high quality your line pipe coating may be, if there is a weaker section at every 12 or 18 meters of pipeline, the reliability of corrosion protection system cannot be very high. Feedback from pipeline owners has identified that field joint coating is one of the areas of a pipeline where corrosion is most frequently encountered. There is a need for a field joint coating that meets the same performance characteristics as a 3-layer PE or PP mainline coating system. This has been made possible by a collaboration between a machinery manufacturer and a coating raw material producer. Together, they developed a machine that can rotate around the welded joint and apply reactive polyethylene or polypropylene materials as a molten film on the FB and also on the cutback area within the intercoating time, as is done in a factory applied coating. This system moves in a small truck parallel to the pipeline route. After welding of the pipeline, the joint area is blast cleaned to required roughness, while the machine is refilled with molten polymer from an extruder on board the truck. The machine is lifted onto the welded area of the pipe and locked in with a clamp system. For smooth movement of the machine around the pipe, it is designed in such a way that the center of gravity of the machine coincides with the pipe axis. In the first rotation, a small induction heating plate hits the surface of steel substrate to 120 degrees centigrade only, and FB is applied. Now, low temperature does not allow FB to cure, but just holds it in place. A set of hot air blowers also heat up the parent coating in the cutback area for proper welding. Now, in the second rotation, it is heated up to 180, 190 degrees centigrade when the epoxy starts curing, and this is when the polyethylene is applied. Being reactive PP, it bonds with the FB and also it welds with the parent polyethylene, and the peel strength is more than 200 Newton per centimeter, which is far above ISO 21809. Now, after the joint coating is complete, it moves to the next joint, and on board the truck, the machine is refilled again. The joint cools by itself. This gives a hermetically sealed system. So this stands out in two aspects. Number one, here P is welded to P, so it's a complete moisture-proof system. And number two, it is machine applied, so the human skill factor is completely eliminated. These are from the project of Gasum, the National Oil and Gas Company in Finland, for a 90 kilometer 500 mm 80 bar gas pipeline. Now, why Gasum selected this? Because they had a test rig where the pipe coating is scratched by stones cast in concrete, and up to 2 tons load can be put on those concrete slabs below which the pipe is pulled. So they have evaluated shrink sleeve, line pipe coating and this new fill joint coating, and they found the performance is excellent. Since they projected many HDD sections, therefore they simply changed over from the conventional fill joint coating to this kind of coating. Coming to the conclusion, 3-layer polyolefin coating solutions for corrosion protection of steel pipelines have come a long way, and continuous innovations are taking place. We have shown you bimodal hexene PE system and low temperature PP system will help to broaden the design window for 3-layer polyolefin coating. New fill joint coating solution will increase the reliability of the CLPO coating pipeline as a whole. All this will help to satisfy the unmet needs of the value chain. Thank you very much for your patient hearing.
Thank you, Mr. Dasgupta. Anybody has any questions, please?